main aim of the project is to make low voltage and high voltage indicator and also overload indicator and temperature indicator. And for temperature indicator we are using LM35 sensor, and for to vary the voltage we are using the potentiometer. There will be various loads to be operated at some specific intervals. For this purpose, a person should be employed to monitor the status of loads. But there is a chance for a person to forgot to operate the loads. And to operate these loads, we are using 8051 microcontroller, and it will operate the loads automatically. Taking the main supply to the transformer. This is a 230 by 12 step down transformer, and this 230 volts whatever getting from the main supply we will get to 12 volts AC, and this is the power supply board which is used to get 12 volts DC and 5 volts DC to operate the microcontroller and ADC boards. And whatever the fans we are using here will operate on DC mode power supply. And here this is a power supply board. Whatever the 12 volts AC getting here will convert into DC by this bridge rectifier, and the capacitors used here are used to take out the ripples from the DC circuit, and this is a voltage regulator which is used to get the constant DC voltage, and from here we are taking the supply to the microcontroller board. These are the three switches we are used to operate the three loads, load 1, load 2 and load 3, and each load is of 60 watts. These are the triacs, that means switches to operate the loads, load 1, load 2 and load 3. We are used 3-channel triac board, and these are the 3 triacs to operate 3 loads, and these are the 3 timers used to control the logic over these triacs. This is a current transformer to operate the overload. This is the voltage sensor circuit used to convert the current sensor to voltage sensor. This is an ADC board, that means analog to digital converter. Because microcontroller whatever using here we will get only will only take the digital mode, but whatever the loads we are using for overload, over temperature and over current, we are getting the analog output. So to convert this analog to digital we have used this microcontroller. These are the control pins. And to get the messages we are using the GSM module. GSM module means it is used for wireless communication. To get messages we have to use this GSM module, and we have to insert a SIM card whatever the number we are using, and this LED is used to know the signal purpose. And this is a cooling fan used to reduce the temperature of the transformer. Thank you. The GSM module will initialize and it asks for a number. Then we have to store our number. We have to send a dummy message to the SIM whatever we are inserted in the GSM module right here.
Yes, the number is stored now.
These are the initial conditions we are given in the program. The temperature of the temperature whatever we are given here is the room temperature, and it is a voltage of 220 volts what we are given here, and this is fluctuating because we are not getting the absolute 220 volts voltage. And the current transformer we are using, because the loads are in off position, in display it is showing 0. The main aim of the project is to protect the transformer from over voltage and over current and from over temperature. These are the loads we are used for overload, and this is the potentiometer to vary the voltage, and this is the temperature sensor to change the temperature to the transformer. And first we are checking for the overload. These are the 3 switches we are used to control the 3 loads. To switch on and off the loads we are using the push buttons. Besides that, we are using the potentiometer and LM35 sensor. Now let's on the load number 1. These are 60 watt bulbs. When the switch 1 is on, the first load will be on, and when the switch 2 is on, the load 2 will be on, and the reading in the LCD screen will be 120 watts, and it is nearly 120. And when the load 3 is on, the load 1 will automatically off because the value given in the microprocessor is 180 watts. And the message will send to the appropriate number which is stored in the GSM module.